Hello, this is my lab report for Lab 5. The purpose of the lab that I chose was to analyze the motion of a falling slinky using a video where a slinky is being held up by one end while the other end naturally stretches out towards the ground, and then the slinky is dropped. Then I used the tracker software to track the position versus time data of the bottom, top, and center of mass of the slinky, then to create a model and to better understand the results of the experiment, I used the principles of spring force, gravitational force, center of mass, and Newton's second law. So some of the physics principles that came into play in my lab were gravitational force, which is negative mass times the gravitational constant in the y direction. The spring force, which is negative ks times the unit vector L, with k being the spring stiffness, L being the length of the spring, L not being the relaxed length of the spring, and the unit vector L being a vector that points from the fixed end of the spring to the moving end of the spring, and in this case that will be pointing up away from the gravitational force. And adding those two forces together gets the net force in the y direction, and when that is equal to 0, that means that something is at rest or moving at constant velocity. Then in order to find the center of mass of this slinky, I used this formula, and since we're just looking at one object, all the masses are going to be equal to the same, so they can cancel out, and that will just be equal to the average of all the points on the slinky. And then in the code, I will be using the position update formula and velocity update formula. And before I show the video of the slinky falling, I'm going to be going over the possibilities of what could happen. So first, the bottom of the slinky could fall first, pulling the top down with it. Another option is the top of the slinky falls, meets with the bottom, and then they fall together. Or the top and bottom could fall at the same time. Or the top and bottom could both move towards each other, towards the center of the slinky, and fall together once they collapse. So let's see which of those happens. So we can see the bottom of the slinky is remaining stationary. It's not moving at all, while the top is moving at a relatively constant speed. And the bottom is still not moving. It's still at the same spot it was at the very beginning, while the top is continuing to move down towards it. And once they collapse together and the top touches the bottom, they both start going down at the same time. And so the second possibility was the one that happened. And so looking at a code which doesn't directly model the experiment, but it's still the same concept. So this is going to have masses representing the slinky here. There's just two masses. So in order to find the forces for those masses, we have L, which is the length of the spring. We have the spring force, and then the spring force is going to be added to the gravitational force for the ball at the bottom, and then it's going to be the spring force is going to be subtracted for the ball at the top. And then here is the velocity update formula, but because we're looking at momentum, it's going to be multiplied by the mass. And then here is the position update formula. And so this is what it looks like with just two masses. So it's just the top moving down towards the bottom, and then once we have a lot more masses, this is what it looks like. So we see the top is moving down towards the bottom, and once it touches, they both move down just like it did in the experiment. And this is what the graph looks like, with this being the top, this being the center of mass, and this being the bottom. And here is that side by side with the experiment model. So we see they're pretty similar. We see that the top is still moving at a constant rate. Then we have the center of mass in between the bottom and the top, and the bottom starts off not moving, and then it starts moving once it touches the top. So let's try to explain why this happens. So when at the beginning, there is tension in the slinky, and so when the slinky is stretched out and the top is being held, the bottom is being pulled up with a force that is equal to the gravity pulling it down. So it is the slinky is at equilibrium to start with. And then once the top is released, the bottom is still being pulled upwards by the spring force, and that is why it's remaining stationary. We can also think of it as the center of mass drops from the start, and its motion is actually exactly that given by the constant acceleration due to gravity. So the slinky contracts at a rate of 9.81 meters per second squared, which is the gravitational constant, and it drops at the same rate as well. And the reason that the top is moving is because the opposite happened. So the force pulling it down is double the gravitational force. And the reason that it's moving at constant velocity is because as the slinky falls, it's being compressed, and that means that the spring below the top is compressed and pushing up. So that is why this experiment works the way it works. Thank you.